In problem 1, we have Claire's got a recipe, uses 9 1/3 cups of flour to make 4 cakes. Noah's going to use the same recipe. We're using C for cakes and F for flour. And they want us to choose a correct equation to represent that relationship. Of course, our hint tells us make a table. And you can also see that for each of our options, C is the letter that is by itself. So when we're making our table, we put it on the right side. So as you can see, C is on the right side. Okay, so in order to write an equation, we need to find the constant of proportionality, but we need to convert our mixed numbers, 9 1/3, into an improper fraction first. All right, so now we're going to put that in the table. 9 1/3 is 28/3. Let me put that in the right spot, though. And now to find our constant of proportionality, we need to put the variable on the right side over the variable on the left side. So C over F. So that means we're going to have 4 divided by 28/3. We're going to rewrite that because that's our complex unit rate. So that's going to be 4 divided by 28/3. Put your denominator. And then we're going to keep it, change it, and flip it. So that's going to give us 12/28, which could simplifies down to 3/7. So now we're going to write our equation using C, F, and our constant of proportionality. So we have C equals our constant of proportionality, 3/7 F, and that is option C. All right, so with our next problem, we got Karen walking at a constant speed, 1 mile, 15 minutes. They want to know which equation represents the distance in D that Karen walks in the minutes. As you can see, once again, all of our options are just one letter, D. So if we're going to make a table, we got to put that letter on the right side. So this is where D is going to be. This is where T is going to be. And if you put it the other way around, I mean, that's fine, but you would just end up having to rewrite the equation by reversing the order of the letters and then also finding the reciprocal. Anyways, so this just saves us some time. All right, so if I have T for time, that's 15 minutes, D for distance, that's 1 mile, and then to find my constant of proportionality, I put the variable on the right on the top and my variable on the left on the bottom. So I have distance over time, so that's going to be 1 over 15. So now I have my equation, D equals, because the variable on the right goes by itself on the equal sign, D equals, and then my constant of proportionality, 1/15 times the other variable, T. So the correct option is option D. Moving on. All right, so with this one, we're talking about Diego. It takes him 1/24 of an hour to complete a lap on a circular bike track. So you take an hour, break it up into 24 pieces, 1/24 of an hour. So it doesn't take him too long. Now the track is 1/3 of a mile long. So what is Diego's bike speed? And here's our hint. Keep, change, flip, and order matters. So we're going to go ahead and set this up in the order that they want. When they talk about speed, guys, they're talking about miles per hour. So that means that miles goes first and then hours go second. So if you go back to your reading, it was actually 1/3 that goes to miles and 1/24 that goes to hours. So the way I set it up with miles on top, hours on the bottom, but this is a complex unit rate, so we can rewrite it as division. And from here, we're going to keep, change, flip. So that's what it looks like. You're going to end up with 24/3, which is equal to 8. And remember, we're talking about miles per hour. So 8 miles and 1 hour is what it is, which is 8 miles per hour. And on this one, just be careful because they do try to trick you in D. They go hours per mile, right? But again, speed is miles per hour. Okay, so now we're talking about David. He uses a 1/4 cup of apple juice for every 1/2 cup of carrot juice to make a fruit drink. They want to know how many cups of apple juice does he use per 1 cup of carrot juice. So again, the order matters, and we're going to have to do some division with fractions. Keep, change, flip. So since the order matters, they want apple juice first, and then carrot juice second. So just like we said, apple juice goes first, so it's in the numerator, carrot juice second, it goes in the denominator. This is a complex unit rate, so we're going to rewrite it using a division with fractions, and that's going to involve the method keep, change, flip, which is going to look like this. When you multiply fractions, you're going to get 2/4, which is equal to 1/2. So basically, you get a half a cup of apple juice for 1 cup of carrot juice. And there you have it. Okay, so in this situation, we have a graduated cylinder. Just imagine like a cup, and it has 7.5 milliliters of water. This is what it actually has, like the real amount. But Han measures the volume of water inside, and his measurement is just 7 millimeters. Remember, millimeters are really small, so to be off by half of a millimeter, that's like really, really close. It's almost hard to see just like with your eyes, without like a microscope or a magnifying glass or whatever. So it says, which of these is closest to the percent error of Han's measurement? Now, the way you calculate percent error is just basically a percent. You find how much you are incorrect by, divide that by the actual amount. So it's real simple. The basically the amount of error, to find that, you have 7.5 is what it actually is. Take away what he said it was, and the difference is the amount of error that he had. So it's basically just 0.5 millimeters. And you're going to divide that, this is your division, divide by the actual amount, which was 7.5, and you're going to get 0.06 repeating. However, you can't leave it in pure decimal form. You have to convert it back into a percentage. So we're going to move the decimal, not one space, but twice. That's going to be 6. But because it's a repeating decimal, we can't just say it's 6%. It's actually 6.6, and then the 6's keep on going. So what you're going to do is, if you look at your options, obviously A is out, B is out, C is out. The only one that looks close enough is D. And if you were to round it up, you could say that because this right here is higher than 5, then you're just going to round up to 7. So this would be 6.7 rounded. And so your answer is D. Okay, another percent error problem. Jar contains gumballs. Your guess is that there's 300 gumballs, but there's actually 400 gumballs in the jar, and they want to know the percent of error. So what you got to do is divide the amount of error by the actual amount. So that's easy. To find the amount of error, there was actually 400, but you guessed 300. So what was the amount of error? Well, we were off by 100. And if you take 100 and divide that by the actual amount, which was 400, 100 divided by 400 is 0.25. But once again, they don't want the decimal version. They want the percentage. So you have to move it not one space, but twice. So that would be, instead of 0.25, you're going to get 25% error. Okay? Okay. And last but not least, we got the situation with Michael. And he's estimating the distance from the free throw line to the hoop, and he marks it with his chalk. He estimates 13.5 feet, but the actual distance is 15 feet. So to find the amount of error, you're going to take your 15, subtract your 13.5. There's no decimal there, so you have to make it, instead of 15, it's 15.0, same thing. When you do your subtractions, you're going to get a 1.5 foot error. But then you have to divide it by the actual amount, which was 15 feet. So 1.5 divided by 15 is, you're going to get 0.1, same thing as 0.10. But this is just a decimal version. We want the percentage, so we move it not one space, but 2 spaces. So instead of 0.10 or 0.1, you're going to get 10%. So the error was 10%.